So coming to the next topic for our Java basics, we will be discussing about functions. So what exactly are functions? Anyone in class, anyone online? If you have any questions, just unmute yourself and start speaking because I won't be able to check the chat. If you just unmute and directly start speaking, I'll be able to hear you. Everybody will be able to hear you in class. So anyone, do you know what functions are?
Another name for it is methods.
Exactly, yeah. And like how do you define what a method is or what a function is?
So it's like um, a set of instructions for, like, you're keeping that for if it's going to be used multiple times.
Yes, exactly. So basically, this concept of a function or a method comes from a different programming paradigm. We have learned about object-oriented programming, where every object has a certain set of behavior, which are our methods or functions, or it has its state, which is the data members that the object has. So before we reach the entire concept or paradigm of object-oriented programming, we had something called functional programming. So functional programming is where this entire logic of modularization originated, wherein the entire concept was to break down our code into small modules or small parts which are rewritten. So instead of rewriting them, we'd be storing them in one place and then directly referring to that particular piece of code and reusing them. So a function is basically nothing but, I hope that the screen is visible. A function is basically nothing but a block of code which has multiple things that can be reused in different places. So this reusing part is what led to the concept of modularization, or modular basically means that it's modular, and any modular piece of code can later on be referenced wherever as and when required in our main application that runs. So as you know, Java and the Java compiler is very sequential in nature. It will start from the first line, and every time the compiler reads a statement, it will read the statement, do whatever is supposed to be done, and it will know the statement ends based on the semicolon that is given. So Java compiler by nature, anything in the C family usually goes line by line. That is why it's very sequential in nature. So so whenever people tried solving different problems, they realized that there is a lot of pieces of code that they basically end up rewriting again and again. Either it's either as a looping condition, which we will be talking about today, or stuff that just gets repeated based on whatever operation you're performing. So rather than writing it again and again and increasing the number of lines that has to be executed, it also increases the size of the file, which is again not exactly practical, especially for storage purposes. But rather than doing something like that, you take that entire block of code out, make it a little generic, and based on that, you make that block in such a way that this block can later be referenced again in one line, and that the compiler would directly know where it is written and it would directly go and refer to it. So that is how modular programming works, and that is how what functions are inherently, and functions or methods are just different names of saying the same thing. So any block of code, any functions that we have three main things. A function has its name, which is the referral point, which we will be using to invoke it later on. We'll understand more about invoking later. And every function will always have a set of input and a set of output. So whatever comes into a function, and obviously all the statements that are mentioned inside. So whatever statements that are mentioned as part of the input is also called parameters. And whatever the output comes is the return value, or whatever the return statement is. So every function inherently always has an input and an output. It always has a parameter and a return value. Java is a language which is more flexible in nature. So you might have a return value or you might not. Similarly, a function can have an input or cannot. Sometimes by referring to whatever piece of code in your main application, you can call the block in such a way by giving it a certain set of input, and based on whatever input is given, the block will perform certain actions and then process it and return the output, which is the desired thing that we need, back onto our application, which then we can go ahead and use. So this sometimes might be necessary, especially when you have different types of input. So the block has one functionality, and based on the input that is given to it, it will process it and give it back. Sometimes there might be input, sometimes there might not be. So for example, if it's just like a normal statement which is just takes an input, it is just for like, internal purposes, it might do the processing and not give any output. Similarly, there might be situations where it will not take any input, do some processing and then directly give you an output. So different functions behave differently based on its use case. So coming to again the logic of functions, I will now just show you before I show you the screen, I directly write the syntax out. So in Java, every function starts with the return type. Is my screen visible on the Zoom call? Can someone just join and check? Okay, anyway, I'll be explaining these things again in the screen as well after I share my screen. So every function basically has a return type, the name of the function, the set of parameters, followed by the opening and closing, as every block of code in Java has. And inside the function, there might be an optional return statement. So what this basically means is every function has a return type, which basically specifies what is the type of data gets returned. Again, so as we know, Java is a statically typed language. So we have to inherently tell the compiler what is the function, what is the input that it is receiving, and what is the type of output that it's going to be. And we have to make sure that the return type that gets returned here is the same as whatever statement or whatever variable. Yeah. So whatever gets returned. We have to make sure that this is consistent so that the compiler does not throw an error. And we know that after processing everything, the output that the function is going to give, there might be an output, there might not be an output. If there is no output, we'll be putting void as our return type, which basically tells the compiler that no, there is no output that is coming out of this function. If not, we will have whatever return type it is. Now, return types are nothing but another way of saying data types. So data types like integers, strings, Boolean values, or we have characters. So these are the types of data types with that this function can be returned. So if it is going to be returning an integer, we have to make sure that the last statement that returns the value is an integer as well. So coming to the next part of a function is the name. So a name is very important for functions. Have you guys done with class diagrams and object-oriented concepts in the theory class? So you guys know about overriding and overloading, right? So overriding and overloading, it's very important to understand the concept of functions and its signature. So this is what we mean by a signature of a function or a method wherein the return type, the name and the types of parameters. So all of these together is called a signature. So based on this, there can be multiple permutations and combinations of the different types of the signatures of a function. There might be functions with the same name, but we have to make sure that the signature is different, as in either the return type or the parameter has to be different. Even if one of these or two of these are the same, we have to make sure that the third one is going to be different, so that the compiler will later on know when you are invoking the method which one is referred and which one is to be called. So coming to the input that the function takes, the input of the function is called the parameters, as I mentioned there. A parameter can again be any set of variables that you are giving as an input to the function, which can be referred inside the function, and whatever processing has to be done will be executed. Again, as we know, scoping is very important for a function. That is the reason we have our curly braces opening and closing. Every function will have to have an opening and a closing parenthesis to understand the block of code, to understand the scope of the function, which is again why you cannot refer to things that lie outside the function. You can only refer to them if they are global variables or if they are public, as you discussed about visibility modifiers and stuff in the theory class. So we have to make sure either they're public, or we have to make sure that if you need special things that has to be referred inside the function, we send it as part of our parameters, as part of our input. Any questions, guys, online? I'll just quickly go ahead and share my screen. Good. So if you just take a look at this, again, I'm referring to the same resource, tutorials point Java basics. You guys can also refer to it later on if you want to do some own study material. So again, another word for functions is methods. Java usually refers to them as methods. They're basically the same word, can be used interoperably. Looking at the syntax of a function, we have our return type. In this case, it's an integer. You already know what public and static means. Public is basically just a special thing in Java, which is a keyword that tells the visibility of the function. Static again refers to. Have you discussed about static in the theory class? We haven't. Okay, so we'll be covering more about static and stuff next Sunday when we dive more into objects, classes, references, inheritance, those types of things. So static basically says that this function belongs to the class. It does not belong to the object. Again, coming to the basic prototype, we see that the return type is an integer. So the body of the function has to return out an integer. The name of the method is the method name. In this particular case, there are two inputs. There are two parameters, which is integer a and integer b. They're both variables. We can see that the parameters are present inside the normal parentheses and the scope of the function is inside the angle brackets. Guys, online, any questions? I see there's one message. If so, yeah, same thing that's mentioned here. What public and statics are, they're the modifiers. Integer is our return type. The name of the method, a and b are our parameters, and which is the list basically. Now coming to an example, you can see this is a minimum function, which basically takes two numbers and then it returns whichever is minimum inside of it. We will in the theory class we talked about conditional statements, so we'll be discussing more about this now. So methods basically have certain blocks of code, and inside the block of code we will always have a return statement that will get executed in the end. Another example of a method is this print function or print method. The system package internally has the out variable and that has a print method. And in this particular case, the print method is invoked with a parameter of this sentence. This is tutorial's part. So based on that, this sentence is what gets sent as input, and the Java compiler internally understands where to go, read the method, and then prints it out to our function. And okay, now so to use a particular method, to invoke to a particular method, what we do is we just write the name of the method and then we call the parentheses with the input and the semicolon. If there are no inputs, we make sure that the parentheses are present, but it's empty. So all of this part will not be there. Another example is there is a sum function, there is a sum method, and that is given an input of 6 and 9 as two integers. And whatever resulting value is coming out of this method is directly assigned and stored inside the result variable, which is also of type integer. One more thing, we have to make sure that whatever the return type that is given by this method is the same as the variable that it is stored. For example, integer in this. Yeah, another example of the same thing, how to use methods. Void keyword, yeah, this is the example of a void keyword wherein we know that, for example, look at the main function. We always write public static void main. The reason for writing main as void is because main is a function that never usually returns a value. So that is the reason our main function is usually void. You can have different values, but again, that is not something that the compiler wants or needs because the main function is just executed once. It is the starting point of the execution. It is where the entire application begins. So it doesn't necessarily have an output because whatever execution is to be done is done inside the main function itself. So in this case, there is a method rank points method, which is again also a void method. That is the reason it is directly invoked. This is how you invoke. As I mentioned, the name with the parentheses and the input and the semicolon, and it is not assigned to any variable since it is not returning it. If you look at the method rank points method, you can see there is if and there is an else statement which we will be discussing now. But internally, there are more methods that gets invoked, but nothing is returned. There is no return keyword present. That is the reason this is also a void method. Similar to main. Main is also a void method. Any questions, guys?
So I have a question. Why does there have to be a return? Like there is obviously a return output, but what if we just keep most methods void and just like put everything as
Yeah, so again, so coming to a block of code, there might be your method is going to be very generic. It is going to take certain inputs that which is obvious, and based on whatever input that you will be taking, you will do a lot of processing. So in this processing situation, there might be scenarios where it will directly affect global variables. So by global variables, variables that are public and that are part of the object or part of a different place. So anything that is out of scope of this, which is fine. Usually you don't do that, but if it is like changing what the environment of the application, it is fine. But usually we write methods in such a way, the whole concept of modularization basically states that it is you're making the piece of the block of code, the piece of code very generic. Right. So that it works for any type of input that you get for any types of scenarios. So every time there's a different type of input, we will always have a different type of an output that we get. So to get this output, we make sure that we are returning something out of the function so that we can handle this output securely in our application. So there might be a situation where if there was a certain scenario where we have one type of input, we want to deal with it differently. If there is a different type of input, we want to deal with it differently. Obviously, this entire logic is not part of the method itself. It is for the it is as part of the application scale. It is not specific to this method. Methods are very isolated, which is again a concept from functional programming, wherein the method doesn't care about the outside world. Whatever it does in its scope, in its own world. It will only care about itself. It will take the input it is given. It will be blind to everything else. It will do the processing. It will give out the output. This is also called separation of concerns, which you will be covering in theory class. So separation of concerns is basically a concept wherein it's separating the concern. So this function this method does not have to worry about whatever the outside world is or who is going to be calling it, who is going to be using it. Tomorrow it might be used from the main method, which will be using this particular block of code, or on a later time there might be a different application that will be referring to it. This method does not care where it is being executed. That is the reason you don't directly manipulate global variables, because there might be situations where this will break. Methods, usually when you're creating, they're very isolated in nature. So you always give it an input and make sure that there is an output. If you're not necessarily outputting anything, then you can give void and it can be an empty.
right? No, like my question was that since we are trying to make the method as generic as possible, why don't we just make every method void, and why do we have to keep the like?
So if you make every method void, you would get, whenever you try to return something, where would you store that? So to store the result back into wherever you need it to be, for example, if you look at this method, if you look at this sum method, for example, let's say sum was a method which just did a plus b. Okay, and inside there is a and b that is given, which is 6 and 9. What is 6 plus 9? 15. So it will calculate a plus b, it would calculate 6 plus 9, but it also needs a place to store it, right? Right. So it would make, so you would be, let's say you would be having a temporary variable called result inside the method itself. So once you save it, save 15 inside the result variable, how do you refer to it from the outside world? Again, the scoping issue comes in, because once the function is executed, the scope finishes. So the memory, whatever was allocated to the function, is destroyed. That is part of what is good about Java. There is a thing called garbage collector, which makes sure that whatever memory that is unreferenced and it is no longer needed gets cleaned up and does not cause more memory leaks or problems like that. So this calculation, once it's done and processed, you need to save it so that you can use it at a later time. So to use it, you refer to it, you return that value from the function and you assign it and keep it somewhere. In this case, it is stored inside the result variable, good, which is also of type integer, and you are equating it and assigning it inside that block. Okay, so coming to, so we are done with methods.
What if we write public static main and start the function? Would it be able to give a value?
It might, because I am not sure. If you do not mention a return type, let's try it out, because I am not sure if the Java compiler will assume a return type. usually it would give an error and it will ask for a return type. Let me just check. Let's just make a normal application. If I go ahead and try to run this, things running fine. And you're saying instead of void, if I directly say, see, already my ID is giving me an error saying that the method declaration must have a return type required.
That's syntax, right? It has to be.
It is part of the syntax. It is basically how you write a method, how you define a method. So while defining a method, it is important to have the return type present. So void is a special keyword that just says that there is nothing that is going to be returned inside of it. If there is anything that is going to be returned, we make sure that there is an integer or any particular return type. Again, if you see the IDE is giving me an error saying that although I have written int, there is no return statement inside my body. It is saying there is a missing return tag. So I have to make sure that something gets returned. Now the error will no longer. Even if I try to run it, I believe it's not recognizing itself. Because Java inherently wants the main method to be void. But let me just see if I can post something. Yeah, it's not even recognizing W. It has to have a void keyword, and now it will run because it is given to the entity. So Java inherently the compiler forces the main method to be void. In other languages like C, C++, you can have your main method return an integer because you might be running the application from elsewhere, and whatever is returned by the main method can also be used for a different purpose. Not necessary or for related with this language, but it is another option that can be possible. In case of Java, this compiler is not allowing me to make any other data. There should be a way if I can post. Does that answer your question? I'm sorry, I'm not sure who asked.
Yes, you answered my question. Thanks.
So again, coming to passing parameters by value, we basically mean that whenever we invoke a function or a method, as you can see in this statement, sum 6,9, this 6,9 can either be direct values like this, or it can itself be a different variable that you are using, like a comma b. In this case, you can see n1 and n2, int n1, int n2. In this example, you can see int a comma b or comma int b. So this is basically what you mean by pass by value, which basically means that rather than directly giving it a value, you are giving it a variable, and based on whatever value is stored inside the variable, the processing is done. Yeah, so that's pretty much it. Method overloading, I believe you've already covered in the theory class. We have two methods which are of the same name. In this case, they are both called mean function, but the signature is different. In this function, in this method, the parameter is integer n1 and n2. But in this case, it is a double, which is n1 and n2. Double is again like similar to float, which is for floating point values, but it is more larger, more storage rights. Similarly, the return type for this method is integer. However, the return type for this method is double. So tomorrow, in this particular case, while calculating result 2 or result 1, different inputs are given. For result 1, A and B is given. For result 2, C and D input is given as parameter. And as you can see, A and B are integer, but C and D are double. So although name is the same, the compiler knows which one is to be called, and it will decide. And as you can see, result 1 and result 2 are also of different type. Result 1 has to be integer because this one returns an integer value. This method is returning a double value, that is why result 2 has to be of type double. Yeah, that's it. So again, coming to this keyword, we will talk about during that class of next week. And yeah, so we've spoken about variables in the last class. We covered about functions. Now let's go to more simple concepts that we covered in the theory class. Let's, the last lab session. Let's discuss about what conditional statements are. decision. So every block of code, you will realize that when you're solving the problem, you might have a situation wherein you will want different scenarios to be executed. Even in the example of a function or a method, based on the input, there might be a scenario wherein you want to do different things based on what type of input you are giving. So this, what you can see on screen right now, is called a flowchart diagram, which basically is used to describe the data flow of an application. In this scenario, there are certain nomenclatures. It's not really important, but just to understand the logic I'm showing this diagram, what it basically means is, after the execution starting point of the application, you might have a particular condition. And based on the conditions are always going to result in two scenarios. Either it is going to be true or it's not, it's going to be false. So based on that condition checking, you might want different things to be executed. But in this scenario, if you want a particular thing to happen, if the condition is met, as you can see in the diagram, this particular part of code only gets executed if the condition is true. If not, it will directly skip this and directly go to the other execution of the application, or in this case, it's just ending the program. So what this basically means is decision making allows you to, as a programmer, to mathematically check a few things, use condition checking, and condition checking is again done with conditional operators, which we will be discussing with this, which will give you a true or a false value. Based on the true or false value, you can decide what needs to be executed or what else needs to be executed. In this situation, nothing else is executed, but there might be a situation based on if the condition is met, this is executed, or if this is not met, you want something else to be executed. So we will be discussing that scenario as well. So if I just scroll down, there are different types of conditional statements. These are the four main ones that are supported in Java. There is an if statement. An if statement basically has the condition, and if that condition is satisfied, it will be executed, which is the diagram that you saw before this. There is an if else statement, which is a scenario that I spoke about. There is a condition. If it is met, something will happen. If it is not met, that is the else part, then something else will happen. I will open it and show you the diagram for that as well. There is a nested if statement, which basically is for multiple condition checking. It is the same as the first one, but there are more levels inside of it. And then there is a switch statement, which I will show you the diagram for, which is mainly if you have multiple case scenarios, different things happening for different scenarios. So let's just go ahead and see the first one. I'm just going to open all of them. Yeah, so coming to an if statement, this is the diagram, the flowchart diagram for the statement. It's the same as the first one, it's just structured differently. Conditions are usually in flowchart diagrams, it's represented by a diamond, a rhombus. So if the condition is met, this conditional code gets executed. So this might be a function, this might be a normal line of code, or whatever is required will be executed, and then it will go ahead or terminate. If it is not met, then it directly terminates, or whatever else is there will get executed at this part. So this particular part gets omitted, it does not execute. So the syntactical way of writing this in Java is this. So let's dissect it. So Java has a special keyword called if, and the if keyword basically states that the if statement has begun. It obviously has a starting and a closing parenthesis to represent the block of all the things that has to be executed inside the condition. So now whatever condition that you want to check is mentioned inside the parenthesis, very similar to the input, very similar to the parameter. So in this scenario, the if keyword is followed by the expression, whatever needs to be true or false. And if that is Boolean expression, basically means that it's either going to be true or it's going to be false. And if it ends up being true, all the things inside here, the body of this if block will get executed. Statements will execute if it is true. And then it will come out and do whatever else needs to be. Let's just see an example quickly. As you can see, inside our main function, we have this variable x. It is of type integer. In this case, we are checking if this condition, and we are just printing out one thing. What are we checking? We are checking if x is less than 20. So this is what you call a conditional operator. Let me just show you what the different types of conditional operators are. Okay, this is another very useful website, Java T Point, very similar to Tutorials Point. Everything is very similar. I just need a list of. This is directly from the Oracle website, so you know it's going to be good content. So these are the different types of conditional operators that we have in Java. So what equal to means is that this is used to check if two values on both the side of the sign are equal or not in value. There might be one variable a, there might be one variable b, and if you want to check if both the values that are stored inside the variable is the same, we would use this operator. We would say a equal to b. Similarly, for not equal to checking, we will do a not equal to b. Coming to a greater than checking, we check if very mathematical in nature if a is greater than b or if a is less than b. Similarly, if you want to check equality with it, we will check if a is greater than or equal to b or is less than or equal to. So these are the different types of conditional operators in Java that will allow us to check. At the end, we will know that whatever this result after computation will always give us a Boolean expression. It will either be true if the condition is met. If it is not met, the condition will give the output of false. Based on that, our if statement can proceed either and decide whether it has to be executed or not executed. Yeah, as you can see, this is the example. If we have two variables, value 1 and value 2. Value 1 has the value of 1 and value 2 has the value of 2. Both are integers, as you can see. In this if statement, we are checking if value 1 is equal to value 2. We can't use a single equal to. Can anyone tell me why?
Value 2 would be stored.
Exactly. So single equal to is basically a assignment operator. It will directly assign, like how we saw previously, int sum equal to int result equal to sum method, right? So equal to will basically take whatever is in the right side and store it inside the left. Very similar to value 1 equal to 1. So it will directly save the one value inside value 1. So we have to make sure that we have two equal to signs. So a lot of people, when writing it for the first time, make that as an error. In the second, and if this gets executed, this line gets printed out. In this scenario, since there is only one line inside every if statement, the parentheses are not there. But it is a very good practice to always make sure that parentheses are there, because if there is going to be more than one line, you will need the block opening and closing. So yeah, as you can see in this condition, we are checking if this is not equal to this, then this gets printed. Obviously, first one will be ignored. This will get printed. If value 1 is greater than value 2, 1 is not greater than 2, so this part gets ignored and directly goes ahead. If value 1 is less than 2, yes, 1 is less than 2, so this part also gets executed. And if value 1 is less than or equal to, yes, so 1 is less than equal to 2, as you can see, so this also gets executed. So we know that when you're checking, this one gets checked, this does not execute, this gets checked, this gets executed. While checking this again does not execute, but while checking this gets executed, and after checking this also gets executed. I'm not sure if the output is present, but yeah, this is the output, the first one, and the last two ones. Okay, so coming back to if statement, any doubts with if statements? No. So we'll go ahead with the if else statement. So now before we start the syntax, take a look at the diagram. This is what I meant by conditional checking, where based on the scenario, you have different things happening. If the condition is met, very similar to if statement, this gets executed and it goes ahead. But in this scenario, if it is not met, if the function becomes false, rather than directly going to the head or terminating, we have a different set of code that gets executed. So this is the else part. This is the else part where block wherein the different actions are performed based on whatever we have. It is very simple, very similar to the if statement. If you take a look at the syntax, same thing. The top three lines are the same. There is a if keyword, the expression in our parentheses, which is the condition. The block opens and closes, which is whatever is in the body is inside. Then we have the else keyword, which is also followed by an open and a close parenthesis. And this is the scope. This is the block of the else part where it gets executed if this is false. So if the expression is true, this part will run and then come ahead. If it is false, this part will run and it will go ahead. Both of them, there is no situation where both of them will run simultaneously. That is important to understand when you're doing an if-else statement, because some people might assume that after this, it will go and run. No, it will not. If you have a situation like that, make sure you're using a normal if statement. Here, this part executed if it is true. If not, this will get executed. Both are isolated. Both will only one of them will run at a time. Let's take an example. We have variable x. It is of type integer. It is with the value 30, assigned value 30. And first part is the same. We are checking if x is less than 20. Again, it's a conditional operator. 30 is not less than 20. This does not execute. So the else part gets executed. When you're executing the else part, directly we have the print statement. It will directly get printed. If I scroll down, you'll be able to see the output. The else statement that is then present inside the else part. So coming to the if else statement, this is also called the if else ladder, which is basically one inside the other. It might look very messy, but to understand what is happening is you're chaining multiple if else statement one beneath the other. So this is for multiple conditional checking. If it is true, directly whatever has to happen will execute and it will directly come outside. Else, second check happens. If it is true, it gets executed and then come outside. If this is also not true, then inside my third thing, we have a third condition checking. If this is executed, if it is true, it will get executed, or else this is the final one that gets executed and then come out. So this is like a safety net. This is also another way of writing a nested if-else statement or an if-else ladder, as we call it, because one is inside the other. If you write it syntactically, you can see that it forms a ladder. There is an if, then there is an else if, then there is an else if, then there is an else.
Does NetBeans have that automatic white space or?
Yeah. Any IDE usually, if you try saving it, it will have a formatter option which is formatted for you. When you write it, it will look very. Let's see, it will look very beautifying. It doesn't naturally do it, but I believe there is a formatter. See refactor, not refactor, format. There you go. Try to do something because these are broken, but it gets reformatted. My X, Y, and Z are my conditions, let's say. Yeah. As you can see, it is formatted. Yeah. So coming to the next one, we have a nested if, very similar to what we discussed right now. An if inside an if is called a nested. That's it. You can have multiple layers, you can have multiple checks. So the diagram for it, okay, there is no diagram for it. So basically, if the first one is true, only then the second condition is executed. If not, the second condition is not executed. This case, only if x is 30, we check if y is 10. If not, we don't check only. In this case, this is true, and this is also true. That is why this statement is run. At a time, only one check is done. So if you have multiple checks that you have to do, you can create a ladder like this, one inside the other, inside the other, inside the other. You can go as much deep as you want, and then based on that, it can also have any layer can also have an else, and it can decide which has to be. Questions till now? Coming to a switch statement. So switch statement, so I will write a diagram for this. So this is a final type of decision making statement in the C family or Java mainly, which allows you to have different scenarios for the condition, for the expression, and based on the different scenarios, you want different things to be executed. So rather than the condition being true or false, in this scenario, it might give you like an output. It might be a function call, it might be a checking, it might be anything. And based on that, you can have different case scenarios. And for every case scenarios, you can define different things that has to execute. If none of the case scenarios are present, you can have n number of these. That's what this means. If none of these are present, there is a default scenario and it will directly it will run the default. We have to also make sure that after every block, it breaks and comes out of the condition, or else it will try to run it. So if you look at the syntax for the switch statement, it might be a little complicated to look at, but it is very simple to understand. You can see we have a variable called grade. It is of type character. That is why it is able to hold C. And then I am just switching that grade. I'm just putting directly my variable as my checking, as my expression. If my variable is A, if my grade is A, then this gets printed and it breaks. What break basically means is it will come out. If it is going to be B or C, since B is empty, B or C, it will print well done and then come out. If it is B, it's going to say you passed. F will be better try again and come out. I believe there is a break missing here. So the break also has to be here. This is like a typo. If none of these are there, if the grade is going to be like XYZ, then it will directly go default and be like invalid grade. This is how you can deal with different cases. If in this situation, grade is directly given, you might have another check. Inside there, you can be like a grade equal to A. And then you can have a case true, case false. Doing that is unintuitive because you have an if-else statement. But if you have multiple scenarios, you can deal with them with this. And whatever is going to be inside after case will be your expression output. It might be a string, it might be like a character in this case, it might even be a number, like you saw up, case 1, case 2. So 1 and 2 will be your output that is given by the expression. Yep, that's it for decision making. Any questions?
Will the system print both the outputs?
The outputs for what?
Oh, one will be the case scenario. It is case C, so it will print well done. It will also print your grade is.
Your grade is yes. If you see the output, it says well done and your grade is both of them.
Okay.
This is not inside the switch statement. The switch statement is only till here. Please make sure that you are understanding the scope. This print statement is outside. It is part of your main function. This line is not inside switch. This line is inside main. So this will obviously get it.
Should there be a comma after your grade is comma then plus grade, or it should be just plus grade?
No. So what this is doing is this is just concatenating this string and this string. So it doesn't matter. If you put comma, you will get a comma here.
Okay.
So in Java, I know what you're trying to ask. Let me just quickly explain. So let's say Okay, so now you're trying to ask if system dot out dot you have something here and you're doing comma 1 as compared to the same thing but with a plus, correct?
Yes, yes.
As you can see, we're able to see the error. There is no system forward for okay, let's just wait just for our do you have experienced the different programming language?
Yes, yes.
So in Python or in a different programming language, whenever you put a comma and automatically a space is assumed as part of your output. Java does not take comma. Java needs a concatenation operator as part of the, because the println function or the println method will only take one input, which will directly be your statement that has to be printed. So if you have multiple things, you can concatenate them using the plus operator, or I believe you can also create F string. I'm not sure what it's called, but basically you cannot use commas. You will have to have everything under a single expression.
Okay. I got it.
Java will not take string literals. It will need to be one input, one parameter as part of the println. Even when there are multiple lines, so what you people usually do is they do plus, they come to a different line, write something out, plus come to a different line, right?
There is the backslash n for that, right? New line.
Backslash n you can use, but I'm saying if you have a very long string that is not fitting for you, people usually concatenate it. Sometimes if you have multiple variables inside your string, inside the input, you can, instead of doing it directly writing it, you can give the variable x or something. Rather than doing plus, in some languages you are allowed to do comma, but Java does not support that. Java only needs one parameter, so that is the reason you use plus. Does that answer your question?
Yes, yes.
Okay, so now that we're done with decision making, another important concept that we have in our programming, so we've discussed about if nested states, right? So now we will talk about another important one, which is loop control. So this again refers to something which is very similar to methods or functions. As you can see, this you can take a look at this diagram. There might be a situation wherein based on a particular situation, you will, based on a particular condition, sorry, that you would want to execute something again and again until the condition is satisfied. So one way of doing it is check the condition and write it as a function or write it as a method. But what that would do is that will only check the condition once, execute it, and then go ahead. That is not a scenario that we want. That is not something that we prefer. We want the condition to be checked again and again after execution or before, and make sure that until it is satisfied, you keep doing. So that is where we introduce this concept of looping controls. And looping controls basically, as you can see in the diagram, it will initiate, the application initiates, it will directly go to check the condition. If it is true, whatever you write as part of the condition is written, very similar to an if statement, and then it goes back to the condition. So this condition is checked. That's why it's a loop. It's get checked again and again, and then only if it is false, it leaves the loop. So again, one important concept of looping control is to make sure that this loop has to satisfy some place and leave safely, or else you would be stuck in a situation where it keeps on running and it never leaves. So that is not something that we want. That is not something that we desire. So whenever we are writing this conditional code block, you have to make sure that we are doing some changes here so that this condition gets met and then it leaves easily. Met or unmet, however you are writing your logic, you have to make sure that it leaves easily. Let's take a look at our looping control. So in Java, there are three main types of looping controls. We have a while loop, we have a do while loop, and we have a for loop. We will talk about for loop in the end because it is very similar to a while loop. But a benefit of for loop is that it allows us to deal with that issue easily, and we don't have to worry too much about dealing with it securely. So what a while loop does is, while a particular condition is true, or while a particular condition is true, the entire block of code gets repeated again and again. And as soon as the condition is no longer met, it would not go inside the block and it would directly escape and come. Let's just take a look at the code for a while loop. I'm going to open all of them again. As you can see, this is what a while loop looks like. It is very similar to how we write an if statement. But instead of that, it starts with a while keyword. Inside our parentheses, we have our expression, which is our condition. It will either be true or false. And again, like an if statement, it will open and close. And whatever is inside are the statements that gets executed. Now, it is very important to make sure that inside our statement, inside the body, we are changing something so that this expression sometimes becomes false and it can leave the loop easily. You see the diagram? You can see it with the code as well. While the condition is true, then this block gets executed, and then it goes back to the condition, checked, the block is executed. This loop is repeated again and again. As soon as the condition becomes false, it will safely leave and execute. Let's take a look at an example. In this scenario, as always, we have a variable x. It is integer, it is 10. While x is less than 20, we are printing the value of x. We are invoking or calling the print method. And then we are doing this. And then we are printing a new line, which is what you were mentioning, right, Sai?
Yes.
Yeah. So what this basically does is, this x plus plus is another way of writing x. Okay, I'll just write and show it to you. So x plus plus is another way of writing x equal to x plus 1. This is just a shorthand notation that is allowed in Java. So it's easy for people to understand. It's called the post increment operator. There are two things. There is pre-increment and post-increment. We're not going into details, but what it does is takes the value of x, increase it by 1. Same as this. So in the right side, what I've written is x equal to x plus 1. So I have increased x by 1 and I have reassigned to the value of x itself. So x is now replaced with 1 additional value. So as you can see in this example, in the first scenario, in the first situation, the first iteration or loop, 10 is less than 20. It is true. It gets printed. X becomes 11. New line, and again it goes checking. Now 11 is less than 20. This thing repeats. 12 is less than 20. This thing repeats. 13 is less than 20. It repeats. This thing keeps repeating, and they have made sure that x plus plus is present here. This is the main important part, which basically updates the value of x. So we have to make sure that we are updating the value of x so that there is a point when 20 less than 20 is false, the condition is no longer satisfied, so it will come out of the while loop and program terminates. If you see the output, 10 to 90. As you can see, as soon as 20 becomes less than 20, it is less than. There is no less than equal to. So it is false. It never prints it out. It directly comes out. That's the reason it only reads. You can see print statement up to 90.
So Akshat, in the pre-increment, it's already incremented before adding the value, right? So like
Yeah, so pre-increment is basically written like this. It's plus plus x. It's okay. So semantically, these are the same, but the way it is used by the compiler is different. What x plus plus means is first take x, then add 1. In this scenario, it doesn't really matter, but there might be situations where it will change. So if you're referring to this, it will take x first, do whatever you want to do, and then do the plus 1 part. In this situation, what it means is before you take x, add 1 to it and then give it to it.
because this is asked a lot in coding interviews, and I wanted to see if it will be also asked in exams. And
Yes, so if you're basically, if I have here, let's say, if I have int x equal to 10, okay, and then I'm trying to print this out. So right now what is happening is x is 10. Okay. Now when I try to print x, what is actually happening is it is printing out 10, but x is internally becoming 11. Let's say I'm trying to print it out again. So in one statement I have done x plus plus, and then in the other statement I have only done x. So when I try to run it, you can see that in the first statement x is taken first, your print statement is executed, and then x plus plus happens internally. You don't even know that it's happening. But in the second statement, that's why just to verify, I'm printing x normally, and it's seeing that it has become 11, although I have done this. However, if I do plus plus x, it will make it 11 first and then print it out first. So that's the difference of the pre. That's the difference between pre-increment and post-increment. So in this scenario, it doesn't really matter because what they're doing is take x and then increment it. It doesn't matter if I pre-increment or post-increment it, or I simply do x equal to x plus 1. Right? There are three different scenarios, three different things. Ideally, same thing is happening in the compiler, but the way it's done is different. In this situation, doesn't really matter. Pre-increment, post-increment, normal addition, doesn't matter. In the while loop. So one important part about understanding while loop, again coming to the same pre-increment, post-increment conversation, we are checking the condition before we execute this block. So this is called pre-checking. So when the application begins, this condition is checked. At the initial state itself, if it is not met, it is directly going to come. So this never gets touched. But if it is true, this will execute, the loop begins, it keeps looping. If it is false, then it comes. Now there might be a situation wherein even if the condition is true, you want to at least do this once. So in that type of a scenario, you would do something called post-checking. So you would put this down, you would do the checking later, and then make sure that this is run. So what that would do is, even if it is false, you are running this first, and then you are checking it. If it is false, it will leave. If it is true, it will loop. That is fine. But it ensures that this thing is at least run once. So if you take a look at that diagram, this is to ensure that when you are running it, it is at least run once. This is the diagram for a do while loop. So what it says is, do this and then check. While this is true, keep doing this. If not, leave. What it allows is that block is at least run once. The syntax of a do while loop, again, very similar to a while loop. Starts with the do keyword, opening and closing, which is all the statement that will be repeated. And while closing, we give it the condition with the while keyword and the expression. Again, same expression has to be conditional statement, will give a true or a false output. If it is false, that will make sure that it will happen once and then go out. An example of that, I think we have the same example. The printing. Yeah, same example. X variable is there, it's an integer, it has 10. What do we have to do? We print the value of x, we increment it, x equal to x plus 1, x plus plus, plus plus x, whatever. Print, go to a new line, and we keep doing this while 10 is less than 20. Now, first time this happens, it becomes 11. 11 is less than 20. Second time, 12 is less than 20. 13, 14, 15 keeps going until 20 is less than 20. No comes out. So if you see the output for this, the output is going to be the same, identical. Starts at 10, goes till 19. Because if it was equal to, less than equal to, then it would have gone for another iteration. So every time it goes back to the start of the loop and completes one, it's called an iteration of a loop. So every iteration of a loop depends on the condition. If it is met, it would reiterate.
So is there any example where you would want to run the condition at least once, like a situation where you use do while instead of while?
Okay, let's just take an example. Let's say I'm not able to think of anything top of my head, but yes, there might be a situation where you're like, there is something that has to be repeated, like a computation that has to be repeated again and again, but it has to be repeated until a certain thing is satisfied. Now that would make you think, yes, we need a normal loop. It can be a normal while loop, very simple. But you might realize that at the beginning of your application, it is already satisfied. Okay. However, you might have when in that particular situation, the loop will never start. It will never enter the loop. But for you, there might be a situation wherein you want to make sure that at least it does once and then does the checking part. So for that, you would use a do while loop, which will ensure that the block is in the do part. It does it once and then it will check if it is done, if it is satisfying or not. This is fine. Okay, so before we come to for loop, there is a very important thing again in this code that we have to understand. We see that x starts at 10 and the checking done here is x less than 20. Similar to the previous loop, similar to the normal while loop, we see that the updation is done. X plus plus is done. Now this is very important, and another way of doing a while loop or another way of looping is the for loop. A for loop basically is very similar logically, but the syntax of a for loop allows your loop to have a different type of increment or updation process. So what that means is, whenever in the previous two examples, we had the variable x, which was 10, but both of that particular variable was outside the loop itself. So the loop had no control of that variable. If someone or something had externally changed that value, it might affect the entire operation of the loop. Now we want this looping thing to happen in a very safe way so that it is executed properly and it leaves also properly. So in that type of situation, we always make sure that the variable, something like x, that is also called as an initializer variable or an initialized variable, is part of the loop itself. So in that situation, a for loop is, again, logically it's going to be the same thing. It's just the diagram looks different, but it basically allows you to do the same looping thing in a safe way, wherein we have an initial variable. And while the initial variable condition is satisfied, the loop happens. And while the loop happens, the increment part is also done at the end. So the initialized variable is the one that gets incremented. In the previous example, it was x. x is x plus plus. It's the same thing, but we are doing this in a safe way. And this loop keeps repeating until it is no longer satisfied and it leaves. Now, the most important part of this is the variable that is initialized and that gets incremented is part of the scope of the loop itself. In the previous two example, x was not part of the scope. X had to be manually changed inside the loop. However, x was outside the loop. But in this scenario, whatever variable we'll be initializing or updating or incrementing is going to be the same. Another benefit is you can do the increment part in different ways. You can have different types of loops that will allow you to count up, count down, or count in twos. Stuff like that can also be done in while and do while loops. But using a for loop basically is easier for a developer because if you see the syntax, it is very easy to understand what is happening once you take a look at it. Very similar to for while or do while, everything it's very similar in Java. It starts with the for keyword. It has the initialization part, which is where your variable is declared and your variable is assigned a value. It ends with a semicolon. This is the part that has the middle part is the one that has the condition, which is going to be true or false. Again, one more semicolon. And then you have the updation, which is the incrementation, increment, x plus plus, x minus minus, whatever. And whatever thing is in the opening and closing parentheses is your loop body of the loop. Let's take an example. The previous ones you saw that the loop was like really big, right? There are multiple lines, x was somewhere else, the loop was somewhere else. It was very messy. This is, although it might look scary, it's very simple once you break it down. We have a for loop. We have a variable x that starts at 10. While x is less than 20, this thing keeps happening. And to make sure that it is happening correctly, we have our updation part where x is incremented by 1. X becomes x plus 1. Here also you can write x plus plus, you can write plus plus x, doesn't matter because for loop treats all updations equally. But yeah, x equal to x plus 1 basically means that this will plus 1 and put it back into x. Same way, it starts with 10, 10 goes into x. And then after this ends, 1 gets added, goes back into x, and it keeps checking, keeps happening until this is no longer satisfied. Yeah, that's it for loops. Okay, now before we go ahead, one small thing to understand, the break statement and continue statement. Let's take a look at our basic looping diagram. This is not specific to while loop, do while loop, or for loop. It is a simple looping diagram. It can be implemented with anything, with a while, whatever. Let's say there is a situation wherein the condition is satisfied and you're inside the loop. Okay. During your loop's execution, something goes wrong. And now, whenever something goes wrong inside the loop, there are two scenarios. Either you want to leave the loop and come out, or you want to skip whatever is there and then go to the next iteration. Update the value and go to the next iteration. So whenever there is a situation where you just want to leave everything, leave the loop, come out, we have the break statement. Whenever we put, very similar to the switch case, when break statement was used to directly leave it and come out. Whereas there is a continue statement, which basically means that leave the rest, leave whatever else is there below, update my value, go to the start of the next. So I'm not sure if there is an example of break and continue, but I'll just quickly check. As you can see the description, break statement terminates the loop or the switch and transfers the execution to the statement that is immediately after that. Whereas continue statement, what it does is causes the loop to skip the remainder of the body and then iterate, update the value and go to the next iteration.
Like if you want to skip 1 or 2 values while you are iterating, then that's when you use the continue.
Yes. That's when you can be like, if this is the value, continue.
Okay.
Skip it. Let's take a look at break. This is the diagram for break. As I said, during my condition, if something goes wrong, I can directly break out. Whereas in my continue, if something is there which I don't want, which I want to skip or ignore, I can continue and restart my loop. It is basically the loop is still there. Even in here, the loop is still there. But break and continue are basically statements that allow you to safely play with the control over it. For example, what is this one? Let's continue. Yeah, in this example, don't look at this for loop. The syntax is very different. We won't be discussing this. But in this for loop, you can see that x is a variable that is going over all the numbers. And if x is 30, like you mentioned, if you don't want to print it out, I can directly use the continue keyword and skip it. So the output will become 10, 20, 40, 50. I'm skipping it. Whereas in the break statement, it's the same code. If it is 30, it will break. So it will only print 10, 20. Or everything else 30, 40, 50 never gets checked only because I'm leaving the loop. Yeah, that's it. Just to check the agenda, we've already done variables, we did functions, we did conditional statements, and we did loops. Now we have data structures. We will only be covering one or two today after a quick 5-minute break, and then we will be covering the rest next Sunday. Okay. Starting in the next lab, we will be working on again Java Swing. I'm just reiterating, and yeah, it's all going to be graphical concepts, and we will be using data structures like these to help implement all the stuff that we want to do.
We'll be using mostly array.
I'm just going to pause the recording now. Guys, online, any questions?
Yeah, I just wanted to ask, we'll be using mostly array lists, right?
Yes, so basically we will see that all the types of data that we'll be dealing with in Swing applications are going to be of different types, but we want to treat them like arrays. So rather than using something like a linked list, so array list is internally also a linked list, but it is also providing us with dealing with the linked list, but with the functionalities of an array. So array, there are a lot of benefits of arrays because that's how it is easy for the developer to deal with it, and linked list is more efficient. Combine both of them is array list. Array list is very specific to Java. It is not a concept in other programming languages. We'll just take a quick 5-minute break if you guys want to go to washroom. We only have 30 minutes. I believe our classroom is only till 2:15 p.m. Question, guys, online?
We use the break statement in a loop. At what point will the break statement will be executed?
The break statement gets immediately executed when it is written. Take a look at the example. Sorry, I didn't understand your question. Can you repeat that?
If we write a code where x is true and it should print hello world, it will print hello world continuously for 10,000 times. So if we add a break statement in it, at what time it will break the statement? Yeah, after one hello world or after 100 or 10,000? Can we set a limit to that, or it will just break it?
Exactly. So if you want to put a limit to it, you would be using a condition like this. But if you randomly mention it in the middle, then it would just simply execute whatever is there before it and it will break. I believe, according to what you're saying, it will break after the first iteration. Then the loop will never execute. But we usually write break statements or continue statements with some conditions while checking certain conditions to make sure that the loop is exited safely. In your situation, like you said, if you do print hello world, it will keep on going and it will never stop. So to not have a situation like that, what we do is we will have a counter which will basically update our iteration, keep count of our iterations, and we will say, okay, if the counter reaches a particular limit, we can break.
So we use if statement in the loop.
Yes, we can use, okay, yes, we can use an if statement.
Can you show an example if it is there or
Tell me what exactly was the code that you were referring to? You have a while loop that keeps on going. While true basically means it's an infinite loop. It's just something that we never want. But let's say we have this, and then you are saying we have this, correct? So if I go ahead and run this, it's going to keep on running, and I believe I will have to restart NetBeans.
yes?
So to avoid something like this, what we do is we will have a counter outside, and every time we loop, we will basically be like count plus equal to 1. This is again one more way of writing count equal to count plus 1, or count plus plus, or plus plus count. It all means the same thing. Count plus equal to 1, same shorthand. And I don't want error, I want. And yeah, what I can do is right here. Okay, yeah. So even right now, although my count is updating, what I can say is if my count equal to 100, then I can safely break out of it. So now when I try to run it, my hello is only gets printed 100 times.
I can't see the code. I think you're not sharing the
So I'm
screen.
not sharing my screen. Oh, sorry. No, my screen is being shared. Yeah, NetBeans is not being shared. Not? Yeah. You see my screen now? Are you able to see now? Yes. Not sure who asked the question. Who asked the question?
Ask the question.
Sahil, is there?
Yes, it's clear. Thanks.
Yeah, so basically, to avoid that type of a situation, an infinite loop, I'm forcing it with while true, which is going to go on forever. I am breaking it when this condition is met. So as you can see, my hello is only 19, hello 99 is there. It's the last one. It goes from 0, right? So start with 1, let's simplify. But yeah. If it touches 100, it's going to break. It's no longer going to print. Break allows me to safely exit. Again, we have to understand the difference between break and continue, because in this situation, continue is going to be useless for. So yeah,
Just skipping
what your it will be like hello 99, and my next line should have been hello 101. I don't know why it's running, but my it's on. Running still. It's going to keep running. And my activity monitoring. It's a big thing. If you guys are like new to programming, I know it's like memory and stuff is not something that gets talked about enough. But you have to understand that as a developer, because in today's day and age, there's a lot of memory and there's a lot of storage. So nobody cares about, especially in different domains. Like me personally, I'm a web developer. So when I was working as a developer, nobody cared about how much storage we are using. Nobody was worried about how much RAM is being consumed because performance is no longer a question, especially in the web world, because everything has been optimized really well for the, for the browser. But while programming in our system, we have to understand that we have a certain constraint, set of constraints and limitations, and we as a developer need to learn to work around it and optimize our codes to better, improve our performance. Mostly talked about architects, software architects, because they are the ones who decide how things can be more efficient. But developing and coding is more like manual. Like if you ask Pro Homer, he would not recording it. Okay, so if you ask Pro Homer, he doesn't like coding. I don't believe he's done too much there. He doesn't prefer coding. That's why if you ask him the other course that I study under him this semester, he likes that more because that is software engineering. It's more about big picture, architecture, state diagram, class diagram, and all those tools nowadays have code generation. It's not going to be accurate, but it will give you 60-70% of your job is done. You only have to make small stuff if you know what it is. It is an important skill to have, but it's a different perspective. As a master student, you're focusing more on the bigger picture. You're focusing on the architecture and how. But as a developer, usually mostly you guys have computer science background in the undergrad, you focus more on how to write code, why code is good, how can you write the same thing again. Which is why data structure is not a one session. It's like an entire course. Even algorithms you can get
In real life, but it is.
no, so it is, but it is never used the way it is taught. It is never used that barrel. It is obviously modified. So, and it is very conceptual and theoretical. It's too much fluff. If you talk about dynamic programming, 3D algorithms, it's all very nice to talk about, but while implementing it is the architect's job to keep that in mind and then implement it. Like we know that there are 15 different types of sorting algorithms, but nobody knows what 15 are. Either use a inbuilt one, which is also not the 15 of them. It's two of those combined in a different way and optimized for that platform. So conceptually it's important to know, but have it memorized. People go about coding more like memorizing. We shall we continue? I'll just continue. Yeah, I was still recording. Right.
Don't worry, we're not putting you on record. Like we won't let down.
Okay, so coming to the next topic, we have arrays. So till now, whatever we've spoken about, especially in the last class, we spoke about different types of data types. We have integers, we have different types of variables that we use for our data types or our return types. We have integers, long, float, double, characters, strings, whatever. Let's say now there is a situation wherein we have a set of those variables or a set of those numbers. So rather than creating like a million copies of the same variable, we can create something called an array, which is a very basic structure which allows you to store similar type values in a continuous way, in a sequential way. So as you can see, it's written here, an array is basically a fixed size sequential collection of elements of the same type. An array is used to store like a collection of data, and it is used as a collection of variables of the same type. The same thing written twice, I don't know why. So instead of declaring A, B, C, D, E, F, G, what we can do is we can have an array called numbers, And that numbers can internally have how many ever spaces that we want, and we can refer to them directly using something called indexes. So if you look at the diagram of an array, if you look at the diagram of an array, in this example, we have an array. Array is also a variable. In this case, it is called mylist. And what is actually happening is, in memory, if all the, let's say the size of this array is 10. So all the 10 values of the array are stored sequentially, and they are referred using the square parentheses. Array indexes always start with 0, and they always go up till n minus 1. N is the size of the array. So in this case, if the size is 10, it's going to go from 0 to 9, because 0 to 9 is 10 elements. And just like variables, inside those particular spaces, we have our values that can be stored. So how we can access those variables using the variable name? We will be referring to these using the array name and their particular index inside the square bracket. It can be 0, 1. So now before we go ahead, let's talk about creation of these things. One way of creating arrays, this is the syntax of creating an array. Basically what it means is you write the return type, followed by the array name, and then as always you either end it or you equate it to the set of elements that you want to be. Make sure the semicolon is always there, because people think that since you're closing, you don't need the semicolon. I'm not sure if it is there in this example. Yeah, it's semicolon, because it's a statement, it needs to end. Now this return type can be any data type like integers, characters, a set of strings. Strings are basically like sentences. We have floats, doubles, whatever. An array name is what we will be using to refer to it, and we can directly assign the values. If you do not know what values to be assigned, or if you want to assign it at a later time, what we can do is we can create an empty array in this format by using a new keyword, where you new the same return type followed by square parentheses. That's the same thing mentioned there? Yes. So again, one more thing. If this is usually done when we know the size of the array that has to be. If we do not know the size of the array to be created, what the developers usually do is they mention this part as part of the return type itself. So another way of writing it is you put the return type followed by the square parentheses, the array name equal to new same return type. Let me just show the syntax on screen while I write. Yeah, it's this one. Followed by the size. They are both syntactically the same. You either mention this here or not, doesn't really matter. Since you're going to be putting this here anyway, it will basically mean that it is an array. Later on, when you need to refer to this variable, you can refer to it using its name followed by the index. Now this can be equated to values, or this can be used with checking. It can be referred to in any way. Let's take an example. So in this scenario, we have a variable called mylist, and it is a double array. As you can see, it is written in this way. Now, when we end a statement here, so there is a difference of concept in Java called initializing and declaration. So initialization basically means that you're telling the compiler there is a variable and you're creating it at the same time. So this statement is an initialization statement. So you initialize it by using the new keyword, and you tell the compiler this mylist double array is a new array of double type with the size 10. If you don't need to initialize it right away, you can just tell the compiler that hey, there is a variable I will initialize it later. And then when you need to use it, you can initialize it there before you start using it. So that's when you can directly put the semicolon here and end the statement. Right now, in this example, we are directly initializing it. That is the difference between declaration and so when you directly put the semicolon there, it's a declaring. You're declaring the variable. That's it. You just declare it. You don't give any more information about it. So what the compiler says is, okay, there is an array that's going to be there. I need to keep some memory free for it. In this scenario, you're declaring and assigning it. So that's called initialize. Very similar to how you do int x equal to 10. Very similar to just saying int x.
But my question is, sometimes if we just initialize and don't declare anything, it shows an error or something.
Yes. So when you try to use a non-initialized variable, you will get an error. So for functions, for example, here if I directly say count int count, the Java compiler is smart enough because what Java basically does is it directly assigns count as 0.
Okay.
But when you are initializing an advanced data structure like an array or different data structures that you would be creating yourselves with your own classes and objects, Java would not know, the compiler won't know what to do with it. So later on, yeah, how much memory, what to do with it, what is the size, it will not have any information. Sorry? I heard something from online. Oh, there's a doubt? Tell me. I heard doubt. No question? Okay, so what I meant was if there is an array or if there is an advanced data structure and you try using it later on without initializing it, the compiler would not know what to do with it. So that's when you get an error. In this particular situation, since it's a basic primitive data type, this is an integer is a primitive data type, it is fine. It will automatically start with the value of 0. But yeah, since you're creating an array, we have to make sure that we're initializing it. And to initialize anything in Java, be it a class, an object, anything, we use the new keyword followed by whatever thing that you're initializing. In this case, it's the same return. It might be redundant saying the same thing twice, but it is basically a benefit wherein there might be situations which you will learn later in your theory class where the return types are classes and you would be creating objects by initializing them in a similar way, but you might be initializing it with a different class by using a superclass. So you're going to be learning about inheritance in your theory class. So in situations like that, that's the main reason it is written and repeated twice, right? By creating one variable with the return type, but by initializing also you're again mentioning the type.
I think this is done when you're trying to convert UML diagrams to actual, you're trying to implement them in Java, right?
Right, yes. So when you were trying to do classes and stuff, you would create one class and by initializing it, you would have to create it in a very similar way, like class whatever, the object equal to new class name. Again, processing arrays, like I mentioned, this is one way of processing it. This is the logic of looping through all the elements in the array and just printing them out. We have a variable I, which is going to refer to our index. And the condition that we are checking is that it has to be less than the mylist.length. Now the length is a property, inbuilt property of the array variable. Whenever we do variable name.length, we will get the size of the array. And in the updation part, we're doing I++. And in our loop, we're doing nothing but printing it and accessing the variable with the array name and square brackets I. So this is going to refer to the value, very similar to this diagram, mylist 0, mylist 1, mylist 2. Another example, we have a double variable total with 0, initialized to 0. The same loop we have, but instead of printing it out, we are doing total plus equal to mylist of I. As I mentioned here, to count plus equal to or total plus equal to is the same as count equal to count plus 1 or total equal to total plus 1. It's the same thing or writing it in a different way. So we are adding all the values of the array into the total variable, and after the loop ends, we are printing the total. That's it. Another logic is for finding the maximum element in the array. Here we have a max variable of double type. We are assuming it as the first one. to start. In our loop, we are starting from index 1. So this is the second index, not 0. Since we are assuming the first one, we don't have to repeat that part. We are starting with the next index, going till the end. And every time we are checking if it is greater than max, then we are reassigning max. So every time if this value is going to be more than max, then max will get reassigned. There is no else statement. It's a simple if statement. If it is not greater, this part gets ignored. It goes to the next iteration. In the end, this assumption will then properly give you the max value. We'll have the proper max value, and then we print out the max value. That's it. So that's all about arrays. A situation wherein we have a data structure with sequential fixed size sequential collection of elements which are of the same type. Okay, I don't believe we have time for the other topics today. So next week we will be covering stacks, queues, and array lists, linked lists and array lists. A quick thing about sets. Sets are the same as arrays, but the only difference is that sets are very mathematical. It's the mathematical set. What it means is they can only have unique values.
No repetitions.
No repetition. Yes. So arrays can have any types of values, whereas sets are very can only be unique values. Let me check if there is an inbuilt library for sets. So even for arrays, we would be sometimes be using them directly, like this. But every data structure, once we understand the concept, we are going to be using the inbuilt libraries to refer to them. We can do them directly, but the main reason for understanding them is so that we can know how to use it, when to use it. Even for the other concepts like linked list, array lists, and stacks, we can directly use the inbuilt ones, but we will never understand how it works. So to know how it works, we're understanding the concept first. So if I look for sets in Java, if set is an inbuilt library inside these, you guys have learned class diagrams, right? So you know what extend means. So there is a tree set. So there is a set interface which extends sorted set, which extends navigable set, and that interface is implemented by the tree set class. Really messy, doesn't really matter. You can directly use it. These are all the functions that are supported by set. There is add all, clear, contains basically checks if it is there or not, gives you a true or false value. Used to check whether a specific element is present in the set or not. If it is empty, you either remove, if you give the value, it will remove whatever is inside it. The size, very similar to length. ToArray is an inbuilt function which converts the set into an array so that we can use it as well. One way of a set. In this case, you're creating a hash set. Don't have to worry about what that is, but it is one way of type string set of string values. This is what this angle bracket is. It's a set of string values. As you can see, this is different as compared to this. This was the example where I was saying that there might be a situation where it might be. Yep, that's it for this class. I believe don't have much time. Next week we'll be covering. I'll just stop the recording and I'll also upload the